GM everyone, and welcome back to the Secret Network CosmWasm Developer Bootcamp. In today's video, you're going to learn how to create your first full-stack NextJS application using Secret Network smart contracts. We're going to create a front-end using secret randomness, so we're going to access secret VRF, which is the verifiable random number generator on Secret Network. We're going to access randomness from a Secret Network smart contract, and then we're going to connect it to a front-end. Let's dive in. All right, so this is what you're actually going to be building today. It's a coin flip dApp where we get randomness from a Secret Network smart contract, and then we're going to use that randomness to return a binary, either 0 or 1. And if it's 0, we're going to flip on heads. If it's 1, we're going to flip on tails. So I just pulled this very basic CSS coin code from an open source repo, and then I connected that to a Secret Network smart contract in Next.js. So we connect our wallet, then we click this button to flip the coin, and what's happening here is we have to approve this transaction to get our randomness from the Secret Network smart contract. And then once it returns a random number between 0 and 1, we're going to land on either heads or tails based on what our random number returns. Bam. So we returned 1, and that's why we landed on this color. So let's learn how to make this now from scratch. So if you've been following along, you know that we have the Secret Network CosmWasm developer tutorial here. If you just go to Riders Blockchain and then Secret Network CosmWasm developer tutorials, let's just start by cloning down this repo to our machine locally. We're going to open that up. All right, I'm going to CD into the full stack secret RNG repo. And what we'll see here is we have two folders. We have the RNG contract folder, and we also have the front-end folder right here. So to start, let's just upload and instantiate our RNG contract on-chain, on the Secret Network testnet. So if we open up the RNG contract, I'm actually going to CD into that as well. We'll see we have two main folders here. We have source, which is our contract code, and then we have node, which is where we're actually uploading the contract. So first, let's just look at the contract. Whenever I'm looking at a CosmWasm smart contract, I first like to start with the message file, because this is what the contract is actually doing. So we see we have three main messages here. We have instantiate, execute, query. Our instantiate message, we start with a flip, so a U8 that we instantiate the contract with. I did this mostly just so you can understand what it looks like when you have an instantiation message that's not empty. We also have this flip variant for our execute message, and then we have this get flip variant for our query message. In our state, we have a flip, and then let's just look at the contract really quickly to see how we actually get randomness from a Secret Network smart contract. So if this is your first time working with RNG and Secret Network, it might be handy just to check out the docs really quickly. This is the source of truth for all things Secret Network for developers. So if we go to the secret contracts section of the docs, we can learn more about the randomness API here with Secret VRF. This teaches you everything about how Secret VRF actually works underneath the hood, how to use it in your contract. So the main thing to note is just that we need to make sure we have secret toolkit storage, as well as these CosmWasm STD dependencies in our cargo.toml, which we have here, in order to actually be able to use secret VRF. And the way this works, if we go back to our contract code, is we get randomness from the environment parameter. So if we go to our try flip function, which is what is called when we use the flip variant, it calls this try flip function. And we'll see just how simple this is. All that we want to do is return a number between either 0 or 1. And we get our randomness from the environment parameter here. So you see here we have environment parameter. There's no underscore before it, which means that it's being used. If we had it like this, that means it would not be being used in this method, but here we're using it. We'll see here that we pass two parameters, depths, mutable, and environment. And the way secret randomness works is every block on the Secret Network blockchain contains randomness within this environment parameter. So the way this works is we update state every time we call this function. which is where we're storing our randomness, either 0 or 1. So if we go to state.rs, this is where we're importing our state struct from, and we see we have this variable here, flip, and there's a U8, right? So every time we call that function, we're updating this to either be a 0 or a 1 based on the current block of secret network. So if we go back here, we define coin flip, and we, from this environment parameter, from the current block, we're getting our randomness. We're getting our randomness byte, we're unwrapping it, and then we're using the modulo operator to either return a 0 or a 1. That's what we're doing right here. And that's it. And then we just update the state struct to either be 0 or 1. So within 3 lines of code, you are creating a coin flip function using on-chain randomness from secret network. And then we also just have this query message where we get the flip back. So we just access the state variable here, load that from storage, and then return our state either 0 or 1. So this is the entire contract. That's all we're doing with this CosmWasm smart contract that we're uploading to Secret Network testnet. To compile our contract, let's run make build mainnet reproducible. And all we're doing is just running this make file here, make build mainnet reproducible, which is using Docker, this Docker script to compile our contract. And then once it's compiled, we can upload it to Secret Network testnet. Amazing, that's been compiled. We will see that file here, contract.wasm.gz. That's the compiled contract, our randomness contract. Now I'm just gonna copy that and I'm gonna paste it into our node folder here. And this is what we're going to use to upload our contract on chain. Let's check out the upload script. This should look familiar if you've been following along. Here we're accessing our mnemonic from our environment file here. Again, if this is your first time working with secret contracts, make sure that you always use just a testnet mnemonic where you don't have real funds, because if you were to push this to GitHub, your wallet would be drained immediately by somebody. So just make sure you're always just using a wallet that only contains testnet funds. And let's try this out. So I have my mnemonic here, and then in our upload script, we access the wallet through that mnemonic here. We access the contract file from this contract.wasm.gz file, which I just pasted here. We have our secret network client set up for Pulsar 3, which is secret testnet. And then we have our upload and our instantiate script here. So what's different about this contract as opposed to the contract we worked with in the previous tutorial is now we have an instantiate message, which actually contains a parameter. So if we go back to our contract, let's take a look. And we look at how we define the instantiate message. We instantiate it with a starting flip. So it's just a number that the contract is starting with. That has to be a U8. So that's why if we go back to our upload file here, which is inside of the node folder, you'll see that in our instantiate message, instead of having this be empty, we have a flip, which is a U8. And it can be anything as long as it's a U8. What's going to happen is as soon as we call the try flip function, it's going to replace this flip number with either a 0 or a 1. So you can make it 0, you can make it 1, anything as long as it's a U8. I think that's all we need to know here. Let's call node upload. I'm just going to make sure actually, so I'm going to cd into node. I'm going to make sure that my dependencies are installed with npm install. And that just makes sure that everything in my package.json file is installed, that we have our .env and secret.js dependencies. And then from there, I should be able to run node upload, and it should return a code ID, contract hash, and a contract address if we're successful. Amazing. So there's our hash. I'm going to paste that into our environment file. And there's our contract address. And I wrote two functions for us, which is our execute function and our query function. So execute is just calling that flip variant. So if we go back to our contract, we have flip is our execute message and get flip is our query message. So I'm calling flip here so that we return either a 0 or 1, right? So anytime we call this method flip, what's going to happen is our contract is going to execute. This is what we're calling flip, and then we use the try flip function to return this 0 or this 1. So let's do that. And we don't have to pass anything, right? It just returns either a 0 or a 1. So if this is successful, what it should do is return, we're just going to log the flip transaction. So we won't actually see the 0 or the 1 in this, but then we're going to query this afterwards to see that it was successful. So we're accessing the contract address and the contract code hash that we just instantiated on chain. Now I'm going to run node execute to see if this is working. All right, so we see that our execute message was successful. Now if we run node query, and let's just look at the query function very quickly. So again, we're just calling this getFlip method with this query contract method using secret.js. That should return either a 0 or a 1. All right, so we got 0. Let's just keep executing until we get a 1. And we see that now we have randomness, right? Like it's 50-50, we're either returning a 0 or a 1 each time we call this node execute function. All right, still 0, we're gonna keep doing it. Ah, the magic of true randomness. There we go. All right, finally got a 1. All right, so now that we know that this works and we've already written our query function as well as our execute function, all that's left is just to connect this smart contract to a front end with a Kepler wallet. So let's do that. So rather than just go through this already completed front end code, let's create a front end from scratch so you can get a better understanding of like actually working with NextJS and Secret Network smart contracts. So what we're gonna do is just start with an empty NextJS repo, okay? So if we go back to Google, I'm just gonna search create next application. And we can do this using npx create next app latest. So I'm gonna go back to this full stack secret RNG folder. So now I'm no longer in RNG contract. I'm in this overarching folder here, full stack secret RNG. And I'm going to run npx create next app latest. What's our project name? Let's just call it, I'm calling it live demo for now. And I'm just going to do everything as it is here. So I'm going to say yes to TypeScript, yes to Tailwind, yes to everything. Always say yes. All right, everything's been installed. Now we see we have this live demo folder here. Let's cd into that. And then if we run npm run dev, we should see the starting application. Let's check it out. All right, so this is the application that we're starting with. Now let's just strip it down. So if we go into this app folder to page.tsx, this is where all this front end is actually being designed. I'm gonna remove all of this so that we just have a header that says, I love secret. And we should see those changes. Amazing. All right, so this is what we're starting with. Now, let's turn this into an application that's connected to the Secret Network blockchain. So, where to begin, right? Where to begin? The first thing we probably want to do is creating a button that can actually connect to Kepler wallet, right? We want to access our wallet here. So let's figure out how to do that. So the source of truth for this is just the secret.js documentation. So I'm going here to github.com, secret labs, secret.js. I'm going to control find Kepler. And here is the code to connect Kepler wallet. So we just have this import here, secret.js. So let's actually start by closing this terminal. I'm going to npm install secret.js. So that we can have access to secret.js. Then I'm going to import this. I'm going to import secret.js so that we can access the secret network client. We can delete this next image. We're not using that. All right. And then I'm just going to take the rest of this code here and I'm going to copy it into my next file. So let's just create a function that's called connect to Kepler. It's an async function. Paste that in here. And then we're going to get this error because we're using TypeScript and we don't currently have access to this. Let's see. Yep, property Kepler does not exist on type window and type of global this. So we'll just fix using Copilot, see what it says. Okay, so we're just declaring this global window here for Kepler so that we can have access to Kepler. And now we're getting no errors. All right, and already we're almost ready to go. So we just need to change two things here, which is our chain ID and our URL. So we want to do this on secret testnet, not secret mainnet. So we're going to change this to Pulsar 3 so we can have access to the secret testnet. And then we just need to get the LCD URL for secret testnet. We can just pull that from our upload script. So if we go back to here, to upload, we have that URL right here. And you can also get this from the secret network documentation. Paste that in there. And then this should be ready to go. Let's try it. So we're going to create this button and we're going to say on click, connect to Kepler. And the only other thing I want to do is I want to actually save this to React state. So I want to save the connected wallet address and I want to save this secret network client. So let's just use state with React so we can save our state here. Like this. I'm just going to paste this in. So we're using use state to save the state of our secret network client as well as the current wallet address. That's all that's happening right here. So that when we click this button, that's now being used in our full stack application. So we're going to say set secret.js. We also want to set our wallet address. And let's also just console.log our address as well, just so that we can see it there. All right, let's try it. Let's click this button. So now when we click this button, connect to Kepler, we will save our secret network client as well as our wallet address that we're actually going to be using in our full stack application. So let's run this again. I hope there's no errors. So it's giving us this error that this React hook only works in a client component. To fix this, mark the file with the use client derivative or directive. So I'm going to paste use client up here and then this should work. It's just something that's specific to React, to NextJS. There we go. So now we have our I love secret header and we have our connect to Kepler button. So if I click this, it should connect my wallet, which I think is already connected. Let's see. So I'm going to click connect to Kepler. And then there you go. That's my wallet address that's connected. And if you also want to see the secret client that's connected, we can do that as well. We can just console.log that. So let's see that. And then now you see everything about our secret client. So we see my wallet address, we see the chain ID, Pulsar3, and the LCD URL and everything else. Now what we want to do is pull in our query function that we already wrote, as well as our execute function. So I'm going to go back to my node folder here. I'm just going to find those functions. So I have my flip function here. And I also have my query function. Let's grab that as well. All right, so I just pasted our flip function that we already wrote and our query function, because those are what we're gonna want to call for our full stack coin flip application. It's given us these errors about secret.js, wallet address, contract code hash. So let's just make sure we point to these parameters correctly. In order to do that, let's just make this so that TypeScript is okay with secret.js. So that's how we do that. We just say if there's no secret.js, console.log, this error, secret.js client is not initialized. So that solves that. And then we just need to fix wallet address, contract address, and code hash. Let's point to these variables in our code. I'm going to take the contract address and code hash that we already deployed on chain. So I'm just going back into our RNG contract file here to our environment variable. And I'm going to grab this for our contract address and this for our contract hash. All right. And we want to use our current wallet address for these functions. So we're going to say the sender is the wallet address as string. And this is just something specific to TypeScript. I think we have to say as unknown as string. I don't know why that is. Let's also do that for our flip function. Oh, we're also getting this secret.js error here. So we just have to say this, if no secret.js, return this error. All right, so now we have our full stack application with our query flip function and our try flip function configured. Let's just add those buttons as well so that we can see that that's working. So both of these, what they're going to do is they're going to console the flip query. They're going to log the flip query, and they're also going to log the flip transaction. Let's try that. And it's very ugly right now. I'm aware. Please know that. We're not worried about beauty right now. We're worried about practicality. So if I query the flip, we should still have 1 from when we previously executed it. Oh, and it's probably because we have to connect our wallet. Okay, so now that we have our wallet instance connected, query the flip. Look at that, we're returning 1. Now let's execute flip. Incredible, right? There we go. Already we're doing it. So I'm going to approve that transaction. And then it should log the transaction here. There you go. You have all the information about the transaction, all the events that are part of this, coin spent, coin received, transfer message, etc. And then we can query it again, and we can see if we are still at 1 or 0. Oh, look at that. We had a flip successfully. All right, so hopefully you're feeling excited at this point. We already are accessing the smart contract that we just deployed on chain. We already have it connected to a front end. Now let's just make it pretty. For the sake of time, let's just go into the completed application and review that code really quickly so you just see how that all looks. I don't want us to design that from scratch just because it would take a while, and that's not really what this lesson is about. The main thing I want you to see is just how all of that code is connected to this NextJS front end. So I'm going to exit out of this. Now, instead of being in this live demo repo, I'm going to open up our front end repo. Cool. I did that with npm run dev, which is what we use to open up our NextJS application in localhost. So the only thing that you need to do now to set up your code to look like this is just some CSS styling. Which let's learn how to do that right now. Perhaps this is your first time working with Tailwind. If so, fret not. It's just like CSS, but a little bit more particular to itself. You can learn about Tailwind CSS if you'd like from their documentation here. It's very straightforward. It's good. It's helpful. But let's just dive into our styling very quickly. So in our front end code, this is the completed code repository for our front end. If you open up app, you'll see page just like what we are working in. And you will also see this globals.css. So this is where we define the coin CSS here. We have some code commentary here just to kind of explain what's happening, but it's very straightforward. This is where all the animation is happening, like the spinning and the flipping. It's just really basic CSS. So I don't want to walk you through that because this is not a CSS tutorial, but just know that that's where this is actually happening, is in this global.css file. And then if we go back to page, we'll see that this looks exactly like what we were just working with. It's just a little bit more done up. So we're declaring this global window so that we can access Kepler for TypeScript. The only difference with our state variables here is we also have this is spinning that we're using to define when we're not spinning. We have our connect wallet function, which looks exactly the same of what we just created. The only difference here is we have this handle coin flip, where again, we're using this, if there's no secret.js, return an error so that TypeScript can access our secret network client. And then this is where we're actually doing the fun CSS stuff. So we're just accessing this coin ID and then removing either the blue or the red class list, depending upon if a 0 or a 1 is returned from our secret network contract. So here you can actually see us executing the execute script. So this is where we're calling flip, and this is where we're calling query. And then all that's happening is that we return this result, and we say if the query returns 1, return side blue, else return side red. That's it. And we have this time. We also set a timeout for 1 second where the coin is spinning. Down here you can see our Tailwind code, but literally our entire front end here, it's in like, what is this? 22 lines of code using Tailwind CSS and Next.js. And with that, we get this finished product with a really fun coin flip application that's connected to our Kepler wallet and is getting real-time randomness from the Secret Network smart contract that we deployed on-chain. All right, everybody, thank you so much for watching. Today you learned how to design your first full-stack Secret Network application using Next.js. You deployed your very own randomness contract to Secret Network testnet, and then you learned how to connect it to a front end using Kepler wallet and how to create your own front end design so we can create a full-stack coin flip application. In our next video, we're going to learn even more intricacies of working with Secret Network smart contracts and connecting them to front ends. And I'm just super excited to see what you continue to build as we continue on with this CosmWasm Secret Network Developer Bootcamp. Thanks, everybody. Be sure to like and subscribe to Secret Network so you'll be notified when there's new developer content. And looking forward to speaking with you again next week.